Great. Well, this is just a wrap up of the buggy lab. The first thing we saw was that the position graph looked nothing like the buggy did. When we did the disc down the ramp, we saw the graph was a curve. And this meant a lot of things to a lot of people, but the clearest thing was that the amount of time that the spinner rolls doubles, the displacement more than doubles. We had some discussions on, does it go 2 times bigger, or 3 times bigger, or 4 times bigger? In general, especially the third hour class said, as time goes up twice, the position goes up, about 4 times. It about quadruples. And we even said if time went up 3 times, we would expect the position to get 9 times as big. But the real important part is that it more than doubles. That's different than the dune buggy. The dune buggy would just double. It was very proportional. So then we said, well, let's find the slope of a lot of different parts, because the slope would tell us the velocity of the disk. So you did that and you graphed it and you're very happy about it, and you ended up with a graph that looked something sort of like this. And I'm just going to write a generic equation that maybe you had was velocity was equal to 0.50 centimeters a second every second times time plus 0.25 centimeters per second. And some people suggested this might be different if you had a different number of books. So maybe this red one, this one might have been lots of books. And if we did maybe just 1 or 2 books on the ramp, it might look something more like this. Just maybe 2 books. A 2-book ramp. And there's a lot of business here. One thing that we see is this y-intercept. And the y-intercept tends its velocity, so we said it was probably initial velocity. How fast was your disk going at the beginning, right when you let it go? And of course we think that should be 0 meters per second, but there's probably some error associated with that. So this is where you might get a small initial velocity. So this y-intercept, we'll say that that's the velocity at time 0, the initial velocity. So then the question is, well, what is the slope? It has weird units. It has units of centimeters per second every second. And we're going to define this as the rate of change. The slope changed depending if you had 1 book or lots of books. And we actually ended up saying what this really is was the change in velocity over the change in time. How fast the velocity was changing per unit time. And we're going to give that a name called acceleration. And that's our definition for acceleration. The slope of the velocity graph, or how fast the velocity is changing every time. So I'm going to put that down here. The slope here is really just the acceleration. And then we still multiply it by the time. So if you want to figure out how fast your disk is going at any given point, you just have to know the acceleration, how long it's been going for, and how fast it's starting. Hopefully that's helpful to figure out this sucker. Good luck on your lab report.